Term 1, keeping alive for year 9. This is your revision video. So for lesson 1, we looked at efficiency. And the big things to remember with efficiency is sometimes you need to calculate the useful energy. So you'd look at your wasted energies down here, you'd look at your total, and then you'd calculate your useful. Remember, this has got to add up to these 3. And there may be more of these. The equation is efficiency useful over total. So that means divided by the total. So you take this value and divide it by this value, and then times it by 100. That's going to give you a percentage. For food test then, we looked at 3 chemicals to test for 3 different types of food. So starch, the test is iodine. How do I know that there's starch present? Well, iodine's going to go from brown to a dark blue or maybe a black. For glucose, you're going to warm it up. If there's sugar present, if there's glucose present, with Benedict's test, it's going to go from blue to a red. And the more sugar there is, the red it will be. Protein then, you'll test with Burette. And this is a simple test where it'll go from blue to like a violet, a purple, if there's protein present. Healthy eating, 2 main things here. You need to know about these health issues. So if there's too much sugar, you get tooth decay, obesity, and type 2 diabetes. If you've got too much fat in your diet, it can lead to obesity and heart disease. And then you need to be careful how much salt you take because it can lead to high blood pressure. In this lesson, we also did a little bit of calculating BMI. And in order to calculate your BMI, you would use your mass and divide that by your height squared. But the equation will be given to you. Soluble salts then, well, the big thing to remember here is first you have to dissolve, and then you filter the excess off, and then you evaporate the water off to leave you with the salt. So the 3 things to remember is dissolve, filter, and evaporate. And that pretty much is soluble salts. Ions and isotopes. Well, an ion is a charged atom. And you can see I've got a charged atom, magnesium with a 2+. I've got a charged atom there, chlorine with 1-. Well, how many chlorines do I need for every 1 magnesium? There's a top, swap, drop method we can use. So what we would do, we would swap these charges and then drop them to the bottom. So I need 1 magnesium for every Cl. So it's going to be MgCl2. We also learned about isotopes, and an isotope is different atomic forms of the same element. So it's pretty much the same element because it's got the same number of protons, but they can have a different number of neutrons. So that's going to be a bigger or a smaller mass number. So the atomic number, the number of protons, are going to remain the same. So in carbon-12, the protons are going to be the same 6, but you can have carbon-12 or carbon-14. So that means one's got 6 neutrons and the other one's got 8 neutrons. Chemical reactions then, the big thing here is knowing that mass is never lost. And you can only come out with the same things as you put in. So you've got your products this side. So I got CH4 and 2 O2s. And I need to get the same amount this side. So you can see I've still got my 4 hydrogens. I've got 1, 2, 3, 4 oxygens. And I've still got the 1 carbon. So mass is never lost. It's just rearranged. These atoms are rearranged. And then your last 2 lessons, we're looking at motion graphs. So distance time graph. We've got time on the bottom and distance on the side. So as we read in this graph, we can see in 2 seconds, they actually get to 20 meters. Then it stopped at 20 meters as time passes. And then any curve on a distance time graph is going to let you know it's accelerating. Now, there's a way to work out speed because speed equals distance over time. So if I take my distance of 20 and my time of 2, I get 10 meters per second. So I'm able to calculate my speed from these graphs. When we look at the velocity time graphs, now a velocity is a vector quantity, which means it's got magnitude and direction. So as I go up to 5, I can also come back down to -1 or negative on this side. So it's really important to keep that in mind because this is actually slowing down here and this is speeding up. What do we call speeding up? We call it acceleration. So this line represents an acceleration, this incline. This line here doesn't represent stopped anymore because 0 meters per second is down here. So this tells us it's doing 5 meters per second for this amount of time. And then it decelerates back at a constant deceleration. There's one more thing you can do here is work out the distance traveled by using the area under the graph. So in terms of this section here, I can do base times height. And in terms of these sections here, I can do half times base times height to get my distance. And that is term 1, keeping alive.